May 24th, 1941, somewhere over the North Atlantic. Lieutenant Hans-Joachim Jabs peered from the cockpit of his Messerschmitt 110er heavy fighter as his squadron circled the most powerful battleship ever built by Germany. The Bismarck stretched nearly 824 feet below him, her massive 15-inch guns capable of hurling shells weighing over a ton to distances exceeding 20 miles. She had just sunk HMS Hood, pride of the Royal Navy, in a battle that lasted barely 8 minutes. Now the Kriegsmarine's greatest achievement was racing toward the safety of German-controlled ports in France, and Jabs and his fellow pilots had been dispatched to provide air cover against any British attempt at retaliation. The Luftwaffe crews felt confident. Their twin-engine fighters were fast, well-armed, and could easily handle any threat the Royal Navy might throw at Bismarck. Then Jabs saw them. At first, he thought his eyes were deceiving him. Approaching from the carrier Ark Royal, barely visible against the grey Atlantic sky, came a formation of aircraft that looked like they belonged in a museum, not in combat over the world's most modern battleship. They were Fairey Swordfish torpedo bombers, biplanes covered in fabric, with fixed landing gear hanging beneath them like the landing skids of some prehistoric bird. These aircraft had first flown in 1934, an eternity ago in aviation terms. They had open cockpits where the crews sat exposed to the elements, no enclosed canopies to protect them from the -40-degree temperatures and hurricane-force winds at altitude. Their maximum speed was barely 138 miles per hour, slower than many World War I fighters. They looked absurd, antiques challenging the might of modern German naval power. Jabs transmitted to his wingman, his voice carrying barely concealed amusement. The British have sent us string bags. This will be target practice. The Swordfish had earned that nickname string bag from British crews because, like an old-fashioned string shopping bag, it could carry almost anything and seemed to hold together through impossible abuse. But to German eyes in 1941 it looked like a relic, a desperate last resort from a navy that had run out of modern aircraft. What Jabs and the other Luftwaffe pilots did not know, what they could not have imagined, was that within hours these fabric-covered biplanes flying at speeds a modern car could match would accomplish what the entire Royal Navy had failed to do. They would cripple the Bismarck, jam her rudder, and condemn the pride of the Kriegsmarine to a watery grave. The transformation from object of mockery to instrument of victory would be one of the most improbable stories in the history of naval aviation. Origins of an anachronism. The Fairey Swordfish had been designed in the early 1930s when the Royal Navy needed a new torpedo bomber to replace aging aircraft that had served since World War I. The requirements were straightforward but demanding. The aircraft needed to carry a torpedo or bombs, operate from aircraft carriers with their short flight decks and pitching movements in heavy seas, provide reconnaissance capability with long endurance, and be simple enough to maintain under combat conditions aboard ship. What Fairey Aviation produced was a biplane that looked outdated the day it first flew, but possessed qualities that would make it one of the most successful naval aircraft of World War II. The design process had been complex and troubled. Fairey Aviation's first attempt, the TSR Always torpedo spotter reconnaissance, flew in 1933 but proved unsatisfactory. The aircraft was underpowered and handled poorly, particularly at low speeds where carrier landing performance was critical. After the prototype crashed during testing, killing its crew, Fairey went back to the drawing board. The redesigned aircraft, initially designated TSR-2, incorporated lessons learned from the failure. The fuselage was strengthened, the wing area was increased, and a more powerful engine was specified. This aircraft, which would become the Swordfish, first flew on April 17, 1934. The Swordfish was built around a steel tube framework covered with fabric. This construction method was already considered obsolete by the mid-1930s, when most military aircraft were transitioning to all-metal stressed skin construction. The Americans had pioneered this technology with aircraft like the Boeing P-26 fighter and the Martin B-10 bomber. The Germans were producing all-metal aircraft like the Heinkel He-111 and the Messerschmitt Bf-109. Even the British were building modern metal aircraft like the Hurricane and Spitfire fighters. But fabric-covered steel tube construction had advantages that would prove crucial in combat. It was light, easy to repair, and remarkably resistant to battle damage. Cannon shells and bullets would punch through the fabric, leaving small holes that could be patched with doped fabric and glue. Metal aircraft struck by cannon fire would suffer structural failures, torn metal that required major repair or wrote off the aircraft entirely. The Swordfish could absorb punishment that would down more modern aircraft. The biplane configuration was similarly archaic by 1930s standards, but provided exceptional low-speed handling. The two wings, one above the fuselage and one below, connected by struts and wires, generated enormous lift at low speeds. This allowed the Swordfish to take off and land on the short decks of aircraft carriers, sometimes in distances of less than 200 feet with a headwind. The aircraft could fly as slowly as 55 miles per hour without stalling, a critical capability for landing on a pitching carrier deck, where the relative wind over the deck could vary dramatically as the ship rose and fell in heavy seas. This low stalling speed also provided safety margins that monoplane designs could not match. If a pilot misjudged his approach to the carrier deck, he had more time to correct his mistake before the aircraft stalled and dropped into the sea. The wing design itself was a masterpiece of practical engineering. The upper wing had a span of 45 feet 6 inches, while the lower wing was slightly smaller. Both wings could be folded back along the fuselage for storage below decks, a critical feature for carrier operations where space was at a premium. The folding mechanism was simple and robust, requiring no special tools or ground equipment. A handful of deck crew could fold or unfold a Swordfish's wings in less than 2 minutes. The wings were covered in Irish linen fabric, treated with multiple coats of dope to make it taut and weatherproof. This fabric covering would be patched and redoped throughout the aircraft's service life, keeping elderly Swordfish flying years after metal aircraft of similar age would have been retired due to metal fatigue and corrosion. The crew consisted of 3 men sitting in open cockpits. The pilot sat in the front cockpit with a basic instrument panel and controls. Behind him sat the observer, the navigator and bombardier who aimed the torpedo or bombs and operated the radio. In the rear cockpit sat the telegraphist air gunner, responsible for the single 303 caliber Vickers machine gun that provided the only defensive armament. This gun, firing rifle caliber ammunition, was woefully inadequate against modern fighters, but it was all the Swordfish carried. The crew sat exposed to wind, cold and enemy fire, communicating through a primitive speaking tube system that often failed, leaving them to use hand signals. The arrangement of the crew reflected the multiple roles the Swordfish was designed to perform. The observer position required a highly trained specialist who combined the skills of navigator, bombardier, radio operator, and tactical coordinator. These men were officers, usually from the Royal Navy's observer branch, who had undergone extensive training in navigation, bomb aiming, torpedo attack geometry, and radio procedures. The observer's position included a plotting table where he could work on navigation calculations, a bomb sight for level bombing attacks, and controls for releasing torpedoes or bombs. The observer also operated the radio, a bulky wireless set that required careful tuning and Morse code proficiency. The telegraphist air gunner in the rear cockpit was typically a petty officer or rating, an enlisted man who had trained as both a wireless operator and an aerial gunner. His primary responsibility was the defensive .303 Vickers gun, a weapon that had been designed in the 1910s and was thoroughly obsolete by 1940. The gun could fire about 500 rounds per minute, but its rifle-caliber ammunition could barely scratch modern fighters with armor protection. The telegraphist air gunner's second role was to serve as backup radio operator and to keep watch for enemy aircraft approaching from the rear. In practice, the rear gunner's most important contribution was often as an extra pair of eyes, spotting submarines or ships that the pilot and observer might miss. The engine was a Bristol Pegasus Radial, a reliable 1680 horsepower power plant that was simple to maintain and could run even with significant battle damage. It gave the Swordfish its maximum speed of 138 miles per hour at 4,250 feet, though most operations were flown at lower speeds around 90 to 100 miles per hour. This agonizing slowness would prove to be one of the Swordfish's greatest assets in ways that no one anticipated when the aircraft was designed. The Pegasus engine was an air-cooled 9-cylinder radial, a type of engine that had proven reliable in harsh conditions. Air-cooled engines were simpler than liquid-cooled engines, having no radiators or coolant systems that could be damaged by enemy fire or freeze in Arctic conditions. The Pegasus could lose 1 or even 2 cylinders to battle damage and continue running, albeit with reduced power. The main offensive load was a single 18-inch torpedo weighing 1,610 pounds, or up to 1,500 pounds of bombs, or depth charges, or mines, or rockets in later variants. The Swordfish was indeed a string bag, capable of carrying almost any weapon the Royal Navy could devise. The standard torpedo was the 18-inch Mark Thorwind, which carried a 388-pound Torpex warhead and had a range of about 1,500 yards at 40 knots. Torpedoes were expensive and complex weapons, each costing more than an automobile in 1940. The torpedoes were modified for airdropping by adding a wooden tail assembly and a nose brake to prevent them from diving too deep when they hit the water. Setting up a torpedo for an attack required careful preparation by the observer, who had to set the depth setting, arm the pistol, and ensure the gyroscope was properly calibrated. Tsarkdas's early service and hard lessons. The Swordfish entered service with the Fleet Air Arm in 1936, and by the outbreak of war in 1939 equipped 12 frontline squadrons. Initial combat experience in 1939 and early 1940 was mixed. The aircraft performed well in reconnaissance and anti-submarine roles where its long endurance and ability to operate in terrible weather proved valuable. But attacks on German shipping and naval units revealed the vulnerability of a slow, lightly armed biplane against modern defences. Losses in daylight operations were severe enough that the Royal Navy shifted Swordfish operations primarily to night attacks, where darkness provided protection that speed and armour could not. The first significant combat operations revealed both the potential and the limitations of the Swordfish. In September 1939, shortly after war was declared, Swordfish from HMS Ark Royal conducted searches for German submarines in the North Sea. The long endurance of the Swordfish, up to 5.5 hours with auxiliary fuel tanks, made it ideal for these patrol missions. But when Swordfish attempted to attack German warships in Norwegian waters in April 1940, the results were discouraging. German anti-aircraft fire proved deadly against slow-flying aircraft, and Luftwaffe fighters could intercept and destroy Swordfish with relative ease in daylight operations. The Norwegian campaign of April and May 1940 was particularly brutal for Swordfish squadrons. Operating from carriers off the Norwegian coast, Swordfish conducted attacks on German shipping and supported Allied ground forces. The losses were severe. 823 Squadron lost half its aircraft in a single day attacking German positions near Narvik. The slow speed and light defensive armament made Swordfish easy prey for German fighters and flak. The crews pressed home their attacks with considerable courage, but courage alone could not overcome the fundamental vulnerability of a slow biplane in daylight operations against modern defences. Yet even in this difficult campaign, there were hints of the Swordfish's potential. Night attacks proved far more successful. German fighters struggled to intercept slow-flying aircraft in darkness, and anti-aircraft gunners found it nearly impossible to track and hit targets they could barely see. The Swordfish's slow speed, which made it so vulnerable in daylight, became an advantage at night. The aircraft could orbit slowly over a target area, searching for opportunities, then attack deliberately. The long loiter time meant that a Swordfish could search a harbour or coastal area for an hour or more, something faster aircraft could not do. It was in night operations that the Swordfish began to demonstrate its unique capabilities. On the night of November 11, 1940, 21 Swordfish from the carrier HMS Illustrious attacked the Italian fleet at anchor in Taranto harbour. Flying at wave-top height to avoid radar detection, the ancient biplanes penetrated one of the most heavily defended harbours in the world and torpedoed 3 Italian battleships, sinking one and severely damaging 2 others. The attack, accomplished with the loss of only 2 Swordfish, shifted the balance of power in the Mediterranean and proved that carrier-based torpedo bombers could achieve strategic results. More importantly for our story, it demonstrated that slow, obsolete aircraft flown with skill and courage could accomplish missions that faster, more modern aircraft might fail to achieve. The planning for Taranto had been meticulous. British intelligence had been monitoring the Italian fleet for months, using reconnaissance photographs to map the harbour defences and the positions of ships. The attack was timed for a night with a full moon, providing enough light for crews to see their targets, but not so much that they would be easily visible to defenders. The Swordfish approached at different altitudes and from different directions to confuse the defences. Some aircraft flew at 8,000 feet and dropped flares to illuminate the targets for the torpedo bombers attacking at wave-top height. The coordination required exceptional skill from crews who had trained intensively for this specific mission. The results exceeded even optimistic expectations. The battleship Conte di Cavour was hit by a torpedo that tore open her hull and sent her to the bottom of the harbour. She was later raised but never returned to service. The battleships Littorio and Caio Duilio were both severely damaged and out of action for months. Additionally, one cruiser and 2 destroyers were damaged by bombing attacks. The Italian fleet, which had outnumbered the British Mediterranean fleet, was suddenly at a significant disadvantage. The balance of naval power in the Mediterranean had shifted in a single night because of an attack by obsolete biplanes. The Japanese studied the Taranto raid intensely, learning lessons that would inform their attack on Pearl Harbor 13 months later. Japanese naval officers recognized that the Taranto attack had proven the vulnerability of battleships to air attack, even in defended harbors. They also noted the importance of detailed intelligence, careful planning, and coordination of attacking forces. The similarities between Taranto and Pearl Harbor were not coincidental. The Japanese had learned from the British how to use carrier-based torpedo bombers to achieve strategic surprise and devastating results. The Germans also studied Taranto, but they drew the wrong conclusions. German naval officers concluded that the Italians had been incompetent in their defence, that properly alert defences would massacre slow-flying torpedo bombers. The Swordfish's success at Taranto was dismissed as a fluke, the result of Italian inadequacy rather than British capability. This misunderstanding would cost the Kriegsmarine dearly. German commanders believed that their modern ships, with excellent anti-aircraft defences and fighter protection, could easily defeat any Swordfish attack. The notion that fabric-covered biplanes could threaten the might of the Kriegsmarine seemed absurd. By May 1941, the Swordfish had been in frontline service for 5 years, an eternity in wartime aviation. Newer aircraft were in development, modern monoplanes with enclosed cockpits and better performance. But the Swordfish remained in service because it worked, because it could operate from carriers in weather that grounded more modern aircraft, because maintenance crews could keep it flying with minimal support, and because, despite all logic and reason, it kept accomplishing its missions. When the Bismarck broke out into the Atlantic in May 1941, it would be Swordfish that the Royal Navy would call upon to stop her. The Bismarck Crisis. The Bismarck's breakout had been a disaster for the Royal Navy from the start. The new German battleship, accompanied by the heavy cruiser Prinz Eugen, had slipped through the Denmark Strait between Iceland and Greenland, intending to raid Atlantic convoys. The Royal Navy had dispatched HMS Hood, the largest warship in the British fleet, along with the new battleship HMS Prince, of Wales to intercept. The resulting battle on May 24th was catastrophic for Britain. Hood exploded and sank in minutes, killed by a shell from Bismarck that penetrated her deck armour and detonated in a magazine. Of her crew of 1,418 men, only 3 survived. Prince of Wales was damaged and forced to break off. The Bismarck, seemingly invincible, was loose in the Atlantic. The loss of HMS Hood shocked Britain. The Hood had been the pride of the Royal Navy, the largest warship in the world when she was built, a symbol of British naval power that had visited ports around the world in the 1920s and 1930s. She was supposed to be unsinkable, her massive size and heavy armour making her immune to enemy fire. The fact that Bismarck had destroyed her in minutes suggested that the German battleship was an unstoppable menace. The psychological impact of Hood's loss was immense. If Hood could be destroyed so easily, what chance did other British ships have? The Admiralty in London faced a nightmare scenario. Bismarck could devastate Atlantic convoys, sinking the merchant ships that kept Britain supplied with food, fuel and war materials from America. Every capital ship in the Royal Navy that could reach the area was ordered to intercept, but Bismarck was fast, could outrun most pursuers, and was heading toward the coast of France where Luftwaffe air cover would make her untouchable. The British had perhaps 48 hours to stop her before she reached safety. If Bismarck escaped, she could operate from French ports against convoys, a strategic disaster Britain could not afford. The strategic situation was desperate. Britain in 1941 was fighting alone against Nazi Germany. The Soviet Union had not yet been invaded and was still nominally allied with Germany through the Nazi-Soviet Pact. The United States was neutral, though increasingly supportive of Britain through programs like Lend-Lease. But Britain depended absolutely on merchant shipping to survive. The island nation could not feed itself or supply its military from domestic production alone. Every week, convoys from North America brought food, fuel, aircraft, weapons, and raw materials across the Atlantic. German U-boats were already sinking hundreds of thousands of tons of shipping each month. If a battleship like Bismarck joined the U-boats in attacking convoys, the losses could become unsustainable. The hunt for Bismarck involved virtually every major British warship in the Atlantic. The battleships HMS King George IV and HMS Rodney, the battlecruiser HMS Renown, the aircraft carrier HMS Victorious, and numerous cruisers and destroyers were deployed to find and destroy the German ship. But the Atlantic is vast, and Bismarck had disappeared after the battle with Hood and Prince of Wales. British ships searching for Bismarck were handicapped by limited fuel and the need to protect convoys. Time was running out. The only force in position to intercept was Force H based at Gibraltar, built around the carrier HMS Ark Royal, the battlecruiser HMS Renown, and the cruiser HMS Sheffield. Ark Royal carried squadrons of Swordfish, obsolete biplanes facing the most modern battleship afloat. The disparity seemed hopeless, but the Swordfish was all the Royal Navy had. On the evening of May 26th, after Bismarck had been relocated by RAF Coastal Command, after being lost for 30 hours, Ark Royal launched her first strike of 15 Swordfish. In the deteriorating weather and poor visibility, the attacking aircraft mistook HMS Sheffield for Bismarck and launched torpedoes at their own ship. Sheffield, aware that Swordfish were operating in the area, managed to evade all torpedoes, some of which exploded prematurely due to faulty magnetic detonators. The strike returned to Ark Royal in humiliation. The Swordfish had attacked their own side and achieved nothing. The attack on Sheffield was a disaster, but not a total loss. The incident revealed that the magnetic detonators on the torpedoes were unreliable. These detonators were supposed to sense the magnetic field of a ship's hull and detonate the torpedo without requiring a direct hit. In theory, this would allow torpedoes to explode underneath the ship's keel, where the hull was less protected. But the magnetic detonators were proving to be temperamental, exploding prematurely or not at all. For the second strike, the torpedoes would be fitted with contact detonators only, requiring a direct hit but ensuring detonation. This change would prove crucial, but the attack on Sheffield inadvertently provided crucial intelligence beyond the detonator problem. The crews who had flown the first mission now had experience flying in the terrible weather conditions that prevailed over the Atlantic. They had navigated in near-zero visibility, flown at wave-top height in 40-foot seas, and located a ship-sized target in conditions where visibility rarely exceeded a mile. This experience would be invaluable for the second strike. The crews now knew what they were facing and had developed techniques for operating in conditions that would have grounded less determined aviators. Attack in the storm. At 7:10 p.m. on May 26th, 15 Swordfish launched from Ark Royal for a second attack on Bismarck. The weather had deteriorated further. Rain squalls reduced visibility to almost zero. The wind was gusting to 40 miles per hour. Waves in the Atlantic were reaching 40 feet. These were conditions that would have grounded more modern aircraft, but the Swordfish, built to operate from carrier decks in any weather, pressed on. The launch itself was a feat of seamanship and airmanship. Ark Royal was pitching heavily in the Atlantic swells, her flight deck rising and falling 40 feet as each wave passed beneath her hull. The Swordfish had to be launched when the bow was rising, giving them extra lift as they left the deck. Launch too early, when the bow was falling, and the aircraft might not have enough airspeed to climb away from the water. The deck crew, working in rain and wind, positioned each Swordfish at the launch point, chocked the wheels, and connected the tail to the deck restraint. The pilot ran the engine up to full power, the deck officer watched the ship's motion, and at precisely the right moment dropped his flag, signalling the deck crew to pull the wheel chocks and release the tail restraint. The Swordfish would lurch forward, accelerate down the pitching deck, and stagger into the air with barely enough speed to fly. Lieutenant Commander Tim Coode led the strike, his Swordfish buffeted by wind and rain. The crews flew at 50 feet above the waves, below the worst of the weather, but low enough that German radar would struggle to detect them until they were very close. Navigation was by dead reckoning and compass. There were no sophisticated navigation aids, just maps, stopwatches, and the navigator's best guess at wind drift and ground speed. That they found Bismarck at all in such conditions was remarkable, but find her they did, the massive battleship looming out of the murk, her anti-aircraft guns already firing. The approach to Bismarck required courage that is difficult to comprehend from the safety of peacetime. The crews were flying at 50 feet above 40-foot waves, meaning they had only 10 feet of clearance above the wave crests. In the rain and poor visibility, judging altitude accurately was nearly impossible. A moment's inattention, a wave higher than expected, and the Swordfish would hit the water and disintegrate. The crews pressed on, navigating by stopwatch and compass, searching the grey murk for the shape of the German battleship. What happened next would be analysed by naval historians for decades. The Swordfish, flying at their typical attack speed of around 90 miles per hour, approached Bismarck through a storm of anti-aircraft fire. The battleship's guns threw up a wall of steel and explosive, her 105mm and 37mm flak guns firing hundreds of shells per minute. The volume of fire was so intense that it seemed impossible for any aircraft to survive. But the Swordfish's very slowness became a survival advantage. German gunners had trained against fast modern aircraft. Their guns had sophisticated predictive sights designed to lead fast-moving targets. But the Swordfish was so slow that German gunners overcompensated, their shells exploding where a fast aircraft would have been, but ahead of where the lumbering biplanes actually were. The German fire control systems were designed for aircraft approaching at 200 to 300 miles per hour. The predictive sights would calculate where a target would be in the time it took a shell to reach the target's altitude, then aim at that predicted position. But when the target was only flying at 90 miles per hour, the predictions were wrong. Shells would explode ahead of the Swordfish, the aircraft flying into the debris and smoke of bursts that should have destroyed them but had detonated too soon. German gunners, trained and experienced, found themselves unable to hit targets that were flying slower than they had ever practiced against. More significantly, the fabric-covered construction meant that shells passed through the aircraft without exploding. Proximity-fused flak shells needed to sense a solid metal target to detonate. The Swordfish had so little metal in their structure that many proximity fuses failed to trigger. Shells would punch through the fabric wings and fuselage, leaving holes but not detonating. Pilots reported seeing tracers passing through their aircraft, daylight visible through holes in the wings, but the aircraft kept flying. One Swordfish returned to Ark Royal with over 175 holes in its airframe but remained airworthy. Sub-Lieutenant Charles Friend was flying one of the Swordfish in the attack. His account, recorded after the war, described the surreal experience of flying through the flak barrage. It was like flying through a fireworks display. Shells were bursting all around us, so close that the concussion would throw the aircraft sideways. I could see tracers coming at us, red and yellow lines in the grey murk, and then they would just pass through the wings. I distinctly remember seeing a shell hole appear in my lower wing, a neat round hole with daylight showing through, and thinking we should be dead. But we kept flying, the engine kept running, the controls still worked, so we kept going toward that enormous ship that was trying so hard to kill us. The Swordfish dropped their torpedoes at ranges between 800 and 1200 yards, close enough for accuracy, but far enough to have a chance of escaping the blast if the battleship exploded. Most torpedoes missed. Bismarck, despite her size, was manoeuvring violently, and hitting a moving target from a slow-flying aircraft in terrible weather was extraordinarily difficult. The torpedo bombers had to approach the battleship from specific angles to have any chance of hitting. Approaching from directly ahead or astern gave the narrowest target profile. Approaching from the beam gave the widest target but required flying through the heaviest concentration of anti-aircraft fire. Each pilot had to balance the likelihood of hitting with the likelihood of surviving. But at approximately 9:15 p.m, 2 torpedoes struck. One hit Bismarck amidships and caused minor damage. The torpedo exploded against the battleship's heavy belt armour, designed to withstand exactly this type of attack. The armour held, and while the explosion caused some flooding and killed several crew members, it did not significantly affect the ship's fighting capability. But the second torpedo struck aft, near the stern. This hit, fired by either Sub-Lieutenant John Moffat or one of his squadron mates, the exact attribution has never been definitively established, detonated against Bismarck's port side near the stern. The location of this hit was critical. The stern of a battleship is less heavily armoured than the sides, because naval architects assumed that torpedoes would strike the main belt armour amidships, where the vital spaces were located. The stern contained the steering gear, the massive machinery that turned the rudders and controlled the ship's direction. The torpedo explosion occurred close enough to the steering gear compartment that the shock wave jammed the rudder controls and damaged the steering gear beyond repair. The explosion jammed Bismarck's rudder hard to port. The steering gear was wrecked beyond repair. The massive battleship, capable of 30 knots and mounting 8 15-inch guns, was now locked into a circular course. She could not steer. Her crew tried everything, using engine power to steer, rigging jury steering gear, even attempting to blast the jammed rudder free with explosives. Nothing worked. Bismarck could only steam in circles, unable to reach the safety of French ports, unable to escape the British battleships that were now converging on her position. A single torpedo, fired from a fabric-covered biplane flying at 90 miles per hour, had accomplished what the entire British home fleet had been unable to achieve. Bismarck was doomed. The crew's desperate attempts to repair the steering went on through the night. Divers went over the side in the North Atlantic, trying to reach the jammed rudder to free it or cut it away entirely. The cold water and heavy seas made this nearly impossible. The divers, working in darkness in 40-foot waves, could barely reach the stern, let alone work on the damaged steering gear. Engineers inside the ship tried to rig emergency steering using chains and tackles connected to the rudder post, but the forces involved were too great. The rudder was jammed by tons of twisted metal, and no amount of manpower could budge it. As the night wore on and all attempts failed, the crew of Bismarck realized their ship was doomed. The Swordfish crews did not know they had achieved this critical hit. They returned to Ark Royal through the same terrible weather, several aircraft landing with damage so severe that they were written off after recovery. But all 15 aircraft and their crews returned safely, a remarkable achievement given the defences they had faced. It was not until the next morning, when reconnaissance reported that Bismarck was steaming in circles, that the Royal Navy realised what the Swordfish had accomplished. The obsolete biplanes had condemned the pride of the Kriegsmarine to destruction. The recovery of the Swordfish aboard Ark Royal was almost as dangerous as the attack itself. The carrier was still pitching heavily in the Atlantic swells, her flight deck rising and falling dramatically. The returning aircraft had to time their approach to land when the deck was level, a brief moment between the rising and falling. Too early and they would hit the deck as it was rising, potentially collapsing the landing gear. Too late and they would miss the arrestor wires and crash into the safety barrier or go over the side into the sea. Several Swordfish landed with visible battle damage, holes in wings and fuselage, damaged controls and wounded crew members. The deck crews worked through the night repairing aircraft, patching holes, replacing damaged parts, and preparing the squadron for potential further operations. The end of Bismarck. On the morning of May 27th, British battleships HMS King George V and HMS Rodney caught up with the crippled Bismarck. In a one-sided battle, they pounded the German ship into a burning wreck. Bismarck's guns were silenced, her superstructure was shattered, fires raged throughout the ship. The German battleship fought with remarkable courage, her crew continuing to man their guns even as their ship was demolished around them. But the outcome was never in doubt. Bismarck could not manoeuvre, could not escape, and faced 2 British battleships that methodically destroyed her. Finally, scuttling charges set by her own crew sent her to the bottom. Of her crew of over 2,200 men, only 114 survived. The ship that was supposed to be unsinkable, that had destroyed HMS Hood with contemptuous ease, had been brought to battle and destroyed because a fabric-covered biplane had jammed her rudder. The final battle lasted less than 2 hours but was extraordinarily violent. British battleships fired over 2,800 shells at Bismarck, scoring hundreds of hits. The German battleship was reduced to a flaming hulk, her guns silenced, her crew dead or dying, her hull riddled with holes. When British ships closed to finish her with torpedoes, Bismarck was already sinking, scuttled by her own crew who opened the seacocks to ensure she would not be captured. The exact cause of her final sinking, whether British torpedoes or German scuttling charges, has been debated by historians, but the result was clear. Bismarck went to the bottom of the Atlantic, taking most of her crew with her. The reaction in Germany was shock and disbelief. How could the mighty Bismarck have been defeated by obsolete British aircraft? German naval officers studying the battle initially refused to believe the reports. Surely modern fighters or dive bombers had crippled Bismarck, not antique biplanes. But interrogation of British prisoners and intelligence reports confirmed the impossible. Swordfish torpedo bombers, aircraft that German pilots had mocked, had sealed Bismarck's fate. The Luftwaffe pilots who had laughed at the string bags over the Atlantic now faced uncomfortable questions. Why had their fighters not stopped the Swordfish? Why had the battleship's formidable anti-aircraft defences failed to shoot down slow-flying biplanes? The answers revealed uncomfortable truths about the Swordfish's survivability. The combination of slow speed, fabric construction, and low-altitude approach made the aircraft surprisingly difficult to shoot down. The Me-110 fighters that had been providing air cover for Bismarck were fast and heavily armed, but they struggled to engage the Swordfish effectively. The German fighters would make high-speed attack runs, but their closing speed was so high that they would flash past the Swordfish before their pilots could properly aim. The Swordfish's slow speed meant that German pilots had only a fraction of a second to track and fire. Most attacks missed completely. The Me-110, with a maximum speed over 340 miles per hour, would approach a Swordfish flying at 90 miles per hour, with a closing speed of 250 miles per hour. At that relative velocity, the German fighter would flash past the Swordfish in under 2 seconds from visual range. German pilots found that their fighter would be past the target before they could properly aim and fire. Some pilots tried slowing down by lowering flaps or reducing throttle, but this made their aircraft unstable and difficult to control. The Me-110 was designed to fight at high speed, and slowing to match the Swordfish's speed made it vulnerable to stalling. When German fighters did score hits, the results were often less decisive than expected. Machine gun bullets and cannon shells would punch through the fabric without encountering enough resistance to fully arm their explosive fuses. The rounds would emerge from the other side of the aircraft, having passed through mostly empty space, leaving holes but not destroying structure. The only way to reliably bring down a Swordfish was to hit the engine or kill the crew, both relatively small targets compared to the aircraft's overall size. German pilots discovered that killing a Swordfish required either sustained fire at close range or exceptional marksmanship, both difficult against a slow manoeuvring target. Jagdtas ist courage and sacrifice. The Channel Dash. The Swordfish's success against Bismarck was not an isolated incident. Throughout the war, these obsolete biplanes would continue to achieve results that defied their apparent inadequacy. In February 1942, during the Channel Dash, when the German battle cruisers Scharnhorst and Gneisenau, along with the heavy cruiser Prinz Eugen, attempted to sail through the English Channel in broad daylight, 6 Swordfish from 825 Naval Air Squadron were ordered to attack. Led by Lieutenant Commander Eugene Esmond, the Swordfish flew into a maelstrom of anti-aircraft fire from the German ships and their escort vessels, plus attacks by German fighters. All 6 Swordfish were shot down. All 18 crew members died. Esmond was posthumously awarded the Victoria Cross. The Channel Dash was one of the most audacious German naval operations of the war. The 3 capital ships had been trapped in the French port of Brest, subject to constant RAF bombing that damaged them repeatedly. Hitler ordered them to return to Germany by sailing through the English Channel, a narrow waterway that the British had controlled for centuries. The plan seemed suicidal, requiring the German ships to sail in, daylight through waters where the Royal Navy and RAF could mass overwhelming force against them. But the Germans achieved tactical surprise, and the British response was confused and poorly coordinated. When Esmond and his 6 Swordfish were ordered to attack, the situation was desperate. The German ships were already halfway through the channel, protected by dozens of escort vessels and constant air cover from German fighters. The Swordfish were supposed to have fighter escort from RAF Spitfires, but the coordination failed. The fighters arrived late and were quickly engaged by German fighters, leaving the Swordfish to attack alone. Esmond knew the mission was suicide, but pressed home the attack anyway, demonstrating the extraordinary courage that characterized Swordfish crews throughout the war. The Channel Dash attack was a massacre, but it revealed the courage of Swordfish crews and their willingness to press home attacks in the face of impossible odds. The Swordfish had been sent on what was essentially a suicide mission, attacking heavily defended capital ships in daylight without adequate fighter cover. That they made the attack at all was testament to the determination of the Fleet Air Arm. The Germans who witnessed the attack were impressed despite themselves. These ancient aircraft and their crews had flown into certain death without hesitation. It was, in the words of one German officer, the bravest thing he had seen in the war. Adolf Galland, one of Germany's most successful fighter pilots, and by 1942 a senior commander in the Luftwaffe, witnessed the attack. He later wrote that watching the Swordfish press their attack through overwhelming fire was one of the most moving spectacles he had ever seen. The courage of the British crews, flying obsolete aircraft in a hopeless attack, impressed even their enemies. Galland ordered his fighters not to pursue damaged Swordfish attempting to escape, though by that point all 6 had already been shot down. Finding the right role, anti-submarine warfare. But the Swordfish found its ideal role in night operations and in attacking submarines. The aircraft's long endurance, up to 5.5 hours on anti-submarine patrol, made it valuable for convoy escort. The ability to carry depth charges, bombs or rockets gave it offensive capability against U-boats. And the slow-flying speed, again proving to be an advantage, allowed the observer time to search for submarines on the surface at night. A fast modern aircraft would flash over a U-boat before the crew could properly identify and attack it. The Swordfish could orbit slowly, searching methodically and attack deliberately. The Battle of the Atlantic was the longest continuous campaign of World War II, lasting from September 1939 until Germany's defeat in May 1945. It was a battle for control of the sea lanes between North America and Britain, with German U-boats attempting to sink the merchant ships that kept Britain supplied. At various points in the war, particularly in 1941 and 1942, the U-boats came close to winning. Merchant ship losses exceeded the rate at which new ships could be built. If the U-boats had succeeded in severing Britain's Atlantic lifeline, Britain would have been starved into submission regardless of success on other fronts. The Swordfish became a key weapon in defeating the U-boat threat. Operating from escort carriers, small aircraft carriers converted from merchant ships, or built on merchant ship hulls, Swordfish could provide air cover for convoys throughout their Atlantic crossing. Previously, convoys had been vulnerable in the mid-Atlantic gap, the area beyond the range of land-based aircraft from Britain or North America. U-boats would concentrate in this gap, attacking convoys that had no air protection. Escort carriers closed this gap, and Swordfish were the primary aircraft operating from these small carriers. The addition of rocket projectiles in 1943 gave the Swordfish a potent anti-ship and anti-submarine weapon. 8 60-pound rockets could be carried under the wings, each with enough explosive force to penetrate a submarine's pressure hull or damage a merchant ship. Swordfish equipped with rockets and operating from escort carriers became highly effective anti-submarine platforms. Between 1943 and 1945, Swordfish sank or damaged more U-boats than any other aircraft type in the Fleet Air Arm. The obsolete biplane had found a role where modernity mattered less than endurance and the ability to operate in terrible conditions. The tactics for anti-submarine warfare required patience and persistence. Swordfish would patrol ahead of convoys searching for U-boats on the surface. U-boats spent most of their time surfaced, where they could move faster and recharge their batteries. They could only remain submerged for a few hours before needing to surface. Swordfish patrols forced U-boats to dive, where they were slow and nearly blind, unable to attack convoys effectively. Even if the Swordfish didn't sink the submarine, forcing it to remain submerged prevented it from attacking. When a Swordfish located a U-boat, the attack had to be pressed home quickly before the submarine could dive. A U-boat could completely submerge in less than 30 seconds if the crew acted quickly. The Swordfish would approach at low altitude, and the observer would aim and release depth charges or rockets at precise moments to hit the submarine, while it was still vulnerable on the surface or just below. The explosions would rupture the submarine's hull or damage its diving systems, forcing it to surface where it could be finished off by gunfire or additional attacks. The winter convoys to Russia were among the most dangerous operations of the war. The Arctic weather was brutal, with temperatures far below zero, winds reaching hurricane force, and seas so rough that ice would form on ships' superstructures threatening to capsize them. These were conditions that would ground most aircraft. But Swordfish operating from escort carriers sailed with the convoys, providing air cover and anti-submarine protection. The fabric covering and simple construction proved advantageous in Arctic conditions. Metal aircraft would suffer from frozen controls and brittle metal that could crack in the extreme cold. The Swordfish, with its fabric covering that could flex without cracking, and its simple mechanical systems that could be maintained by frozen-fingered mechanics, kept flying when more sophisticated aircraft were grounded. The Arctic convoys sailed from Britain or Iceland to the northern Soviet ports of Murmansk and Arkhangelsk, carrying military supplies for the Soviet Union. The route took them north of Norway, through waters patrolled by German U-boats, and within range of German bombers based in Norway. The Arctic weather made these convoys nightmarish, even without enemy action. Ships would ice up in the cold, requiring crews to constantly chip ice from decks and superstructures. Men working on deck in these conditions risked frostbite in minutes, and falling overboard meant death from hypothermia within seconds. One particularly notable incident occurred in September 1943 during convoy operations in the Arctic. A Swordfish from 819 Squadron, based on HMS Activity, was on anti-submarine patrol when it spotted a surfaced U-boat. The U-boat was attempting to crash dive but had not yet submerged when the Swordfish attacked. The observer, Sub-Lieutenant Peter Twiss, dropped depth charges that straddled the diving submarine. The U-boat, later identified as U-3 was severely damaged and forced to abort its patrol, limping back to Norway for repairs. Twiss later wrote about the attack, noting that the Swordfish's slow speed had been crucial. A faster aircraft would have overshot the U-boat before the crew could react. The Swordfish could orbit, position itself carefully, and attack deliberately. The stringbag's versatility. The versatility of the Swordfish was demonstrated by the wide variety of roles it filled beyond torpedo bombing. Swordfish flew mine-laying missions, dropping mines in German-controlled harbours and shipping lanes. They conducted anti-shipping strikes against coastal convoys, using bombs and rockets. They performed search and rescue, locating downed aircrew and guiding surface vessels to rescue them. They flew as night fighters, though with limited success given their slow speed. They even conducted gunfire spotting for battleships, observing where shells landed and radioing corrections. No other aircraft in any navy performed such a diverse range of missions. Mine-laying missions were among the most dangerous operations Swordfish crews undertook. These missions required flying into enemy harbours or coastal waters, often heavily defended, to drop mines in shipping channels. The mines were heavy, limiting the Swordfish's performance and making it even more vulnerable to anti-aircraft fire. The missions were typically flown at night to reduce the risk of fighter interception, but this meant navigating to precise locations in darkness to ensure the mines were dropped where they would be effective. German ports like Hamburg, Kiel, and Wilhelmshaven were regular targets for mine-laying Swordfish throughout the war. The mines themselves were sophisticated weapons. Some were magnetic mines that would detonate when they sensed the magnetic field of a ship passing overhead. Others were acoustic mines triggered by the sound of a ship's propellers. The most advanced were pressure mines that sensed the change in water pressure caused by a ship's hull displacing water. These mines would lie on the bottom of harbours and channels, nearly impossible to detect and extremely difficult to clear. Swordfish-laid mines sank or damaged hundreds of German ships throughout the war, disrupting coastal shipping and forcing the Germans to dedicate significant resources to minesweeping. Anti-shipping strikes against German coastal convoys were another important mission. Germany moved significant amounts of cargo by ship along the coasts of occupied Europe, from Norway south to France. These convoys were protected by escort vessels with heavy anti-aircraft armament, and they often operated within range of shore-based fighters. Swordfish attacks on these convoys typically used rockets or bombs rather than torpedoes, attacking from higher altitudes where they were less vulnerable to light anti-aircraft fire. These attacks disrupted German logistics and forced them to divert military resources to convoy defence. Search and rescue missions demonstrated the Swordfish's endurance and the dedication of its crews. When aircraft ditched at sea, or crews bailed out over the ocean, Swordfish would search vast areas looking for survivors in life rafts or floating in the water. The long endurance and slow speed made the Swordfish ideal for these missions. The crew could search methodically, covering large areas over multiple hours. When survivors were spotted, the Swordfish would circle to mark their position and radio their location to rescue vessels. Many aircrews owed their lives to Swordfish that found them and guided rescue ships to their location. The production history of the Swordfish reflects its enduring value. First produced in 1936, the Swordfish remained in production until 1944, an 8-year production run that was almost unprecedented for a military aircraft. Over 2,300 were built across multiple variants. The Mark I was the original production version. The Mark II had strengthened lower wings to carry rockets. The Mark III had radar for anti-submarine work and an enclosed cabin for the pilot, the only Swordfish variant to protect the crew from the elements. The Mark IV was a proposed version that was never built as the war ended. The Mark III represented a significant modification to address one of the Swordfish's major shortcomings. The addition of radar, typically the ASV, air-to-surface vessel, markets radar, gave the Swordfish the ability to detect surface submarines at night or in poor visibility. The radar antenna was mounted between the landing gear struts, a distinctive bulge that identified Mark III Swordfish. The enclosed cabin for the pilot provided protection from the elements, but was controversial among pilots. Many preferred the open cockpit's superior visibility and the ability to feel the aircraft through wind pressure and sound. The observer and telegraphist air gunner remained in open cockpits even on the Mark III. That the Swordfish remained in production long after more modern aircraft were available speaks to its unique capabilities. The Fairey Barracuda, designed as the Swordfish's replacement, entered service in 1943. It was a modern monoplane with better performance, enclosed cockpit, and more powerful engine. But the Barracuda proved troublesome in service, with handling problems and a tendency to structural failure in hard use. Many squadrons preferred to keep their reliable Swordfishes rather than transition to the supposedly superior Barracuda. The string bag, as old-fashioned as it looked, simply worked. The Barracuda's problems were numerous. It was tail-heavy and difficult to control, particularly during landing approaches to carriers. The aircraft had a tendency to stall without warning, a potentially fatal characteristic when landing on a carrier deck. Structural failures occurred in the tail section, particularly during carrier landings when the arrestor hook engaged and the aircraft was suddenly decelerated. Pilots complained about poor visibility from the cockpit and heavy control forces that made the aircraft tiring to fly. While these problems were eventually addressed through modifications, the Barracuda never achieved the reliability and ease of operation that characterized the Swordfish. Life aboard a Swordfish. The crew experience in a Swordfish was unlike any other naval aircraft. The open cockpit meant crews were exposed to the elements. At altitude, temperatures could drop to -40 degrees Fahrenheit. The wind chill from the slipstream made it even colder. Crews wore heavy fur-lined flight suits, leather helmets, goggles, and gloves, but they were still miserably cold on long missions. Frost would form on goggles. The speaking tube system that allowed crew communication would freeze. Hand signals were often the only way the pilot, observer, and gunner could communicate. The flight suits worn by Swordfish crews were specialized equipment designed for extreme conditions. The Sidcot suit, standard issue for Fleet Air Arm aircrew, was a one-piece garment made of heavy canvas with a wool lining and a fur collar. Over this, crews often wore an additional leather jacket and leather overalls. Boots were fur-lined leather, and gloves were thick leather gauntlets. Even with all this protection, crews would return from long missions in Arctic conditions with frostbite on exposed skin. The cold was not just uncomfortable, it was dangerous, slowing reactions and making fine motor control difficult. But the open cockpit had advantages. Visibility was exceptional, critical for spotting submarines or navigating by visual reference. The noise and vibration of the engine and the feel of the wind gave pilots constant feedback about their aircraft's condition in ways that enclosed cockpits could not match. And in an emergency, the crew could bail out simply by standing up and stepping over the side, far easier than escaping from an enclosed cockpit in a sinking aircraft. Many Swordfish crew members who survived shoot-downs credited the open cockpit with saving their lives. The experience of ditching a Swordfish at sea was traumatic but survivable. The aircraft's light weight and fabric construction meant it would float for a short time after ditching, giving the crew precious seconds to escape. The open cockpits allowed crew members to simply climb out and jump into the water, whereas crews in enclosed cockpits of metal aircraft often became trapped as their aircraft sank rapidly. Swordfish crews wore Mae West life jackets and carried survival equipment including emergency rations, flares, and signal mirrors. If they survived the ditching and managed to get into a life raft, their chances of rescue were reasonable if they were operating near friendly forces. The maintenance of Swordfish aboard carriers was remarkably simple. The fabric covering could be repaired by sailmakers using skills that had been standard in the Royal Navy for centuries. The engine was accessible and could be worked on without removing major assemblies. The wings folded for storage, a feature common to carrier aircraft. but the Swordfish's wings were particularly easy to fold and unfold, requiring no special equipment. In rough weather, when more modern aircraft would be secured below decks, Swordfish could remain on the flight deck, their fabric construction flexing with the ship's movement without damage. The maintenance crews who kept Swordfish flying were skilled artificers and mechanics who often worked in difficult conditions. On escort carriers, maintenance facilities were minimal, often just a small workshop with basic tools. Crews would work on the open flight deck in all weather, their tools freezing to their hands in Arctic conditions, their work interrupted by waves breaking over the bow in rough seas. The simplicity of the Swordfish's construction made this possible. More complex aircraft required specialized tools, test equipment, and controlled environments. The Swordfish could be maintained with hand tools, improvisation, and determination. Evolution of tactics. The tactical doctrine for Swordfish attacks evolved throughout the war. Early attacks had used relatively high-altitude approaches, followed by dives to drop altitude, but these proved vulnerable to anti-aircraft fire. By 1941, low-altitude approaches at wavetop height had become standard. The Swordfish would fly at 50 to 100 feet above the water, using the waves themselves to mask their approach from radar and making it difficult for anti-aircraft guns to depress low enough to engage them. The torpedo would be dropped from as low as 30 feet, skipping across the wavetops before entering the water and running toward the target. The skill required to fly these missions was extraordinary. Navigating at night or in bad weather at wavetop height with no modern instruments required exceptional piloting. One mistake, one moment of inattention, and the aircraft would hit the water at 90 miles per hour, killing everyone aboard instantly. The crews who flew these missions were volunteers, highly trained, and exceptionally brave. They knew the odds. They knew that Swordfish losses in combat were severe. But they also knew that their attacks could achieve strategic results, that their obsolete biplanes could sink ships and win battles. The geometry of a torpedo attack required precise calculation. The torpedo, once dropped, would run in a straight line at about 40 knots. The target ship would be moving, typically at 15 to 30 knots, and might be maneuvering to avoid attack. The observer had to calculate the lead angle, aiming not at where the ship was but where it would be when the torpedo arrived. This calculation had to account for the distance to target, the torpedo's speed, the ship's speed and direction, and the Swordfish's own speed and direction. The observer used a simple sight, essentially a metal frame with wires stretched across it to estimate these angles. The calculations had to be done mentally in seconds, while the aircraft was being thrown around by turbulence and anti-aircraft fire was exploding around them. Night attacks added another level of difficulty. Navigation to the target required dead reckoning, using compass, airspeed, and time to estimate position. Stars could provide navigation references when visible, but cloud cover or bad weather made celestial navigation impossible. Crews would navigate by following coastlines when possible, using distinctive landmarks that could be identified by moonlight or starlight. Finding a specific ship in a harbour or at sea at night required exceptional skill and often considerable luck. Comparisons and contrasts. The comparison with other contemporary torpedo bombers reveals the Swordfish's unique characteristics. The Japanese Nakajima B5N Kate was faster, more modern, and carried a heavier torpedo, but it was fragile and its crews were exposed to enemy fire in ways that Swordfish crews were not. The American Douglas TBD Devastator was a monoplane with better performance, but it proved catastrophically vulnerable at the Battle of Midway, where 35 of 41 Devastators were shot down in a single day. The Devastator was retired in 1942 as too vulnerable. The Swordfish fought on until 1945. The German He 115 seaplane was contemporary with the Swordfish, but never achieved comparable results. The Devastator's failure at Midway illustrated the vulnerability of even modern aircraft, when attacking defended targets without adequate fighter cover or coordination. The Devastator squadrons attacked Japanese carriers in daylight, facing concentrated anti-aircraft fire and swarms of Zero fighters. The slow speed of torpedo attacks made the Devastators easy targets. Unlike the Swordfish with its fabric construction that could absorb battle damage, the Devastators were all metal aircraft that would burn when hit. The loss of 35 Devastators and their crews in a single day was one of the costliest air attacks in naval history. The B-5-year-N Kate, used to devastating effect at Pearl Harbor, and in the battles of the Pacific War, was superior to the Swordfish in most performance categories. It was faster, carried more powerful torpedoes, and had better range. But the Kate was also more complex, requiring more maintenance and more skilled ground crews. Japanese carriers had large air groups and excellent maintenance facilities, making the Kate's complexity manageable. British escort carriers, small and Spartan, needed aircraft that could be maintained with minimal facilities and limited spare parts. The Swordfish's simplicity was an advantage in this environment. The Swordfish's success raises interesting questions about aircraft design philosophy. The aircraft was obsolete by conventional standards before the war even began, yet it remained effective throughout the conflict. This suggests that modernity and high performance are not always the most important factors in combat effectiveness. Reliability, ease of maintenance, versatility, and suitability for the actual conditions of combat may matter more than speed or modern construction. The Swordfish embodied these unglamorous but essential qualities. Training the crews. The training pipeline for Swordfish crews was thorough and lengthy. Pilots would complete basic flight training before moving to operational training on the Swordfish itself. Learning to land on a carrier deck required repeated practice, first on land-based training carriers, then at sea on training carriers, before finally qualifying for operational carriers. Observer training was similarly extensive, covering navigation, bomb sight operation, torpedo aiming, and radio operation. Air gunners trained on aerial gunnery and aircraft recognition. A fully trained Swordfish crew represented hundreds of hours of training and significant investment. Carrier landing training was particularly demanding. Pilots would practice approaches and landings at shore facilities that simulated carrier decks, marked out on airfields with arrestor wires and barriers. The key skills were maintaining precise speed and altitude on final approach, judging distance to touchdown, and catching the arrestor wire with the tail hook. A carrier landing required flying the aircraft onto the deck with enough force to engage the arrestor wire, unlike normal landings where pilots would flare to reduce sink rate. This went against all instincts developed in flight training, and learning to fly the aircraft firmly onto the deck required extensive practice. The first carrier landing was a significant milestone that pilots remembered for the rest of their lives. The carrier deck looked impossibly small from the air, a tiny rectangle of steel pitching and rolling in the ocean swells. The landing signal officer, standing on a platform at the rear of the ship, would guide the pilot with signals from coloured paddles. Following these signals while maintaining proper airspeed and altitude required intense concentration. If the approach was good, the landing signal officer would give the cut signal, the pilot would chop the throttle, and the aircraft would drop onto the deck and catch an arrestor wire that would bring it to a stop in less than 50 feet. Observer training emphasized navigation skills that seem almost incredible by modern standards. Observers had to be able to navigate by dead reckoning for hours over open ocean with no landmarks, using only compass, airspeed, and calculations of wind drift. They practiced celestial navigation, taking star sights with sextants to determine position. They learned to use radio direction, finding equipment to locate radio beacons. They mastered the complex calculations required for torpedo attacks, practicing until they could estimate ranges, speeds, and angles instinctively. An experienced observer could look at a ship, estimate its range and course, and calculate the correct torpedo drop point in seconds. The loss rate among Swordfish crews was high, though less than for some other torpedo bomber types. The dangerous nature of low-level torpedo attacks meant that crews faced intense anti-aircraft fire, and losses were inevitable. But the Swordfish's survivability meant that crews had a better chance than in many other aircraft. The fabric construction that seemed so obsolete actually saved lives by allowing aircraft to absorb battle damage and continue flying. Many Swordfish returned to their carriers with extensive damage that would have downed metal aircraft, bringing their crews home alive. Replacement crews faced a sobering introduction to operations. Arriving at a squadron that had been in combat, new crews would find themselves assigned to aircraft that bore the names of previous crews who had been killed in action. The traditions of the Fleet Air Arm emphasised continuity and collective memory. The new crew would take on not just an aircraft, but a responsibility to honour those who had flown it before. This sense of connection to past and future crews created strong bonds within squadrons, and helped new crews integrate into the dangerous world of carrier operations. Strategic impact. Post-war analysis of the Swordfish's effectiveness concluded that it had been one of the most cost-effective aircraft of the war. The aircraft was relatively cheap to produce, costing about 1/3 the price of a modern monoplane torpedo bomber. It required less maintenance than more complex aircraft, reducing the logistical burden on carriers and shore bases. Its versatility meant that a single aircraft type could fill multiple roles, simplifying training and spare parts supply. And its combat effectiveness, particularly in anti-submarine warfare, was exceptional. In terms of enemy tonnage sunk per pound sterling invested, the Swordfish was probably the most effective British combat aircraft of World War II. The total tonnage of Axis shipping sunk by Swordfish exceeded 1 million tons, including warships, merchant vessels, and submarines. This represented a significant portion of the total shipping losses inflicted by the Royal Navy and made the Swordfish one of the war's most successful anti-shipping weapons. The strategic impact of these losses was substantial. Every submarine sunk was one less threat to Atlantic convoys. Every merchant ship sunk was cargo that never reached Axis forces. The cumulative effect of hundreds of successful Swordfish attacks helped ensure Allied control of the seas. The Germans never developed an effective counter to the Swordfish carrier combination in anti-submarine warfare. U-boats were vulnerable to aircraft when surfaced, and the Swordfish operating from escort carriers could patrol large areas around convoys, forcing U-boats to remain submerged where they were slow and had limited endurance. The happy time for U-boats, the period in 1941 and 1942 when they had devastated Allied shipping, ended partly because of the deployment of escort carriers with Swordfish. The obsolete biplane had helped win the Battle of the Atlantic. Admiral Karl Dönitz, commander of the German U-boat force, later wrote that the introduction of escort carriers with effective anti-submarine aircraft was one of the key factors that defeated his U-boats. The ability of Swordfish to patrol around convoys meant that U-boats could no longer surface to attack. They had to remain submerged, where their speed was reduced to a few knots, and their ability to find convoys was severely limited. The U-boats, which had been so effective in 1941 and early 1942, became increasingly ineffective as escort carriers entered service in larger numbers. The final missions, the final operational sortie by a Swordfish occurred in June 1945, after the war in Europe had ended but while Japan was still fighting. A Swordfish from 836 Squadron, operating from a shore base, flew an anti-submarine patrol. No submarines were encountered, and the aircraft returned safely. It was a quiet end for an aircraft that had been in continuous combat operation since 1939, longer than almost any other combat aircraft in the war. The Swordfish had outlasted aircraft designed to replace it, had survived when more modern types had been withdrawn, and had remained effective when logic suggested it should have been obsolete. The story of the Swordfish and Bismarck became legendary, but it was not the whole story of the aircraft's war. The Swordfish had sunk or damaged more Axis ships, submarines, and support vessels than any other British aircraft. It had flown in every theatre where the Royal Navy operated, from the frozen Arctic to the Mediterranean to the Indian Ocean. It had operated from large fleet carriers, small escort carriers, and shore bases. It had carried torpedoes, bombs, mines, depth charges, and rockets. It had flown in conditions that would have grounded any sensible aircraft. And through it all, it had kept flying, kept fighting, and kept bringing its crews home. In the Mediterranean, Swordfish flew from Malta during the island's darkest hours, when it was under constant bombing by the Luftwaffe and the Regia Aeronautica. Operating from bases that were bombed daily, often with minimal fuel and ammunition due to the siege conditions, Swordfish attacked Italian and German convoys supplying Axis forces in North Africa. These attacks helped strangle Rommel's Afrika Korps by sinking the ships carrying fuel, ammunition, and reinforcements. The contribution of these Malta-based Swordfish to the eventual Allied victory in North Africa was significant. In the Indian Ocean and Pacific theatres, Swordfish flew from carriers and shore bases against Japanese forces. They conducted anti-submarine patrols, attacked Japanese shipping, and supported amphibious operations. While overshadowed by the larger American naval air campaign in the Pacific, British carriers with Swordfish participated in operations from Madagascar to Sumatra to Okinawa. The Swordfish proved that it could operate effectively in tropical conditions as well as Arctic ones, demonstrating the versatility that had characterized it throughout the war. Legacy and memory. The preservation of swordfish after the war was limited. Most were scrapped, their fabric burned, and their metal frames melted down. Only a handful survive in museums today, carefully restored examples that give modern viewers a sense of what these aircraft were like. Several are in flying condition, maintained by organizations dedicated to preserving aviation history. The sound of a swordfish in flight, the distinctive rumble of the Bristol Pegasus engine, and the whistle of wind through the rigging wires, is a connection to a different era of aviation. The Fleet Air Arm Museum at Yeovilton in Somerset, England, has several swordfish on display, including examples that served in combat. The Imperial War Museum at Duxford has a swordfish that is regularly flown at air shows, giving modern audiences a chance to see this historic aircraft in the air. The Royal Navy Historic Flight maintains a flying swordfish that participates in commemorative events and air shows. These preserved aircraft serve as reminders of the courage of the men who flew them and the remarkable story of how an obsolete biplane helped win the war at sea. When Lieutenant Hans Joachim Jabs saw those swordfish approaching Bismarck on May 26, 1941, his laughter was understandable. The aircraft looked absurd, antiques that had no business attacking a modern battleship. But the laughter died when Bismarck's rudder jammed, when the great ship began steaming in circles, when the inevitable became clear. Those string bags, those fabric-covered relics, those obsolete biplanes had accomplished what looked impossible. They had condemned Bismarck to destruction through skill, courage, and the peculiar advantages of their seemingly obsolete design. The transformation from object of mockery to instrument of victory was complete. The swordfish had proved that old does not necessarily mean ineffective, that simple can be better than complex, and that the will of determined crews matters more than the sophistication of their equipment. German pilots had laughed at the swordfish until it sank the Bismarck. After that, no one was laughing. The string bag had earned its place in history, not despite its obsolescence, but in some ways because of it. The slowest combat aircraft of World War II had helped win the Battle of the Atlantic, and that achievement speaks to the enduring truth that in war, effectiveness matters more than elegance, and results matter more than appearances. The lessons of the swordfish remain relevant to military aviation and procurement. The drive toward ever more sophisticated and expensive systems can obscure the importance of reliability, maintainability, and suitability for actual combat conditions. The swordfish succeeded not because it was technologically advanced, but because it was robust, versatile, and appropriate for the missions it was asked to fly. Modern military planners studying the swordfish's service record might reflect on whether contemporary procurement priorities properly balance sophistication against practical effectiveness. The human element, the courage and skill of the crews who flew the swordfish, was ultimately more important than the aircraft's technical specifications. The same aircraft that looked like a relic from a museum became a devastating weapon in the hands of determined crews. The swordfish pilots, observers and gunners who flew into flak storms, who searched for submarines in Arctic darkness, who landed on pitching carrier decks in storms, embodied the combination of skill, courage and determination that defined the war at sea. The swordfish's story is ultimately one of unexpected triumph. An aircraft that should have been obsolete before the war began instead served throughout the entire conflict, accomplishing missions that more modern aircraft could not achieve. From Taranto to the sinking of Bismarck, from Arctic convoy protection to Mediterranean anti-shipping strikes, the swordfish proved its worth again and again. The veterans who flew swordfish remembered their service with mixed emotions. They remembered the cold, the fear, the losses of friends and squadron mates. They also remembered the pride of serving in an elite force, the satisfaction of successful attacks, the bond between crew members who depended on each other for survival. Many veterans remained connected through the Swordfish Squadrons associations, gathering annually to commemorate their service and remember those who did not return. The decorations awarded to swordfish crews reflected the dangerous nature of their missions. Multiple Victoria Crosses, Britain's highest award for valour, were awarded to swordfish crew members, including Eugene Esmond for the Channel Dash attack. Hundreds of Distinguished Service Orders, Distinguished Service Crosses and Distinguished Flying Crosses were awarded to swordfish pilots and observers. The rear gunners and maintenance crews often overlooked in official recognition, also received awards for their contributions to the aircraft's success. Technical specifications and variants. A detailed examination of the Swordfish's specifications reveals how its designers achieved such versatility in a simple airframe. The aircraft had a length of 36 feet 4 inches and a wingspan of 45 feet 6 inches for the upper wing. The height to the top of the upper wing was 12 feet 10 inches. The empty weight was approximately 4,700 pounds, while the maximum takeoff weight reached 9,350 pounds when fully loaded with torpedo and fuel. This relatively light weight contributed to the aircraft's excellent slow-speed handling and short takeoff performance. The wing area totaled 607 square feet, giving the Swordfish a wing loading of only about 15 pounds per square foot at maximum weight. This low wing loading was the key to the aircraft's low stalling speed and excellent low-speed handling. Modern fighters of the same era had wing loadings 2 or 3 times higher, which gave them better high-speed performance but made them far more difficult to land on carrier decks. The fuel capacity of 155 gallons gave the Swordfish its remarkable endurance. At economical cruise speeds around 90 miles per hour, the aircraft could remain airborne for over 5 hours, covering ranges of 450 miles with a torpedo or 550 miles with lighter loads. This endurance made the Swordfish ideal for long-range reconnaissance and anti-submarine patrols, where time over the target area mattered more than speed of transit. The Mark I Swordfish, the original production version, equipped most squadrons from 1936 to 1943. This version had metal-framed lower wings and could carry a torpedo, bombs, or depth charges, but not rockets. The observer and rear gunner sat in open cockpits, and the aircraft had no radar. Despite these limitations, the Mark I achieved most of the Swordfish's notable successes, including Taranto and the attack on Bismarck. The Mark II introduced strengthened lower wings with metal covering on the lower surfaces. This modification allowed the aircraft to carry rockets, significantly enhancing its anti-ship and anti-submarine capability. The 8 60-pound rocket projectiles could be devastating against surface submarines or light vessels. Each rocket had enough explosive force to penetrate a submarine's pressure hull or punch through the side of a merchant ship. The Mark II entered service in 1943 and quickly became the standard variant for anti-submarine operations. The Mark III was the most advanced Swordfish variant. It featured ASV, air-to-surface vessel, radar housed in a radome between the landing gear struts. This radar could detect surface submarines or ships at ranges of several miles, giving the crew crucial advantages in locating targets at night or in poor visibility. The Mark III also had an enclosed cabin for the pilot, though the observer and rear gunner remained in open cockpits. The enclosed cabin improved pilot comfort on long patrols but slightly reduced visibility. Some pilots preferred to fly with the cabin canopy open despite the cold, valuing visibility over comfort. The Mark IV was proposed as the ultimate Swordfish variant with an enclosed cockpit for the entire crew, upgraded engines and improved performance. Several prototypes were built and tested in 1944. But by that point the war in Europe was clearly moving toward conclusion, and production of new Swordfish was being wound down. The Mark IV never entered operational service, though the prototypes demonstrated that even the ancient Swordfish design still had room for improvement. Operational squadrons and their histories. The Swordfish equipped numerous Fleet Air Armed squadrons throughout the war, each with its own history and traditions. 825 Naval Air Squadron, which conducted the attack on Bismarck and later was massacred during the Channel Dash, became one of the most famous Swordfish units. Reformed after the Channel Dash disaster, 825 Squadron continued to operate Swordfish until late in the war, flying anti-submarine missions from escort carriers. 810 Naval Air Squadron participated in the Taranto raid and served throughout the Mediterranean campaign. The squadron operated from HMS Illustrious, and later from other carriers and shore bases, attacking Italian and German shipping. 810 Squadron's operations demonstrated the Swordfish's effectiveness in the confined waters of the Mediterranean, where targets were plentiful but defences were strong. 819 Naval Air Squadron specialised in Arctic convoy protection, operating from escort carriers in some of the most brutal conditions of the war. The squadron's aircraft and crews endured temperatures of -40 degrees, hurricane-force winds and seas that could flip aircraft off carrier decks if they were not properly secured. The squadron's success rate against U-boats was exceptional, with multiple confirmed kills and many more submarines forced to abort patrols due to damage. 824 Naval Air Squadron operated in the Far East, flying from carriers and shore bases against Japanese forces. The squadron participated in operations from Burma to the Dutch East Indies, demonstrating that Swordfish could operate effectively in tropical conditions as well as Arctic ones. The challenges of tropical operations were different but no less severe. Heat, humidity, and tropical diseases affected crews and maintenance personnel. The fabric covering of the Swordfish required constant attention in humid conditions where mildew could rot the fabric. The engineering achievement. The engineering that went into the Swordfish deserves recognition alongside the courage of its crews. Creating an aircraft that was simple enough to maintain under combat conditions while being robust enough to absorb battle damage and versatile enough to perform multiple roles was a remarkable achievement. The design team at Fairey Aviation, led by chief designer Marcel Lobel, created an aircraft that embodied practical engineering principles. The steel tube fuselage framework was both strong and simple. Primary structure consisted of steel tubes welded together to form a rigid framework. This framework carried all the loads from flight, landing, and catapult launches. The fabric covering contributed nothing to structural strength. It merely provided aerodynamic shape and protected the internal structure from the elements. This meant that the aircraft could suffer extensive damage to its fabric covering without affecting structural integrity. The wing structure used similar principles. Spruce spars carried the bending loads, while ribs shaped the airfoil. Metal struts and wires braced the wings together and transferred loads to the fuselage. The entire wing structure could be assembled by skilled woodworkers using relatively simple tools. This construction method meant that battle damage could often be repaired in the field without specialized equipment or facilities. The landing gear was robust and simple. Fixed gear meant no retraction mechanism to fail or freeze. The gear could absorb heavy landings on carrier decks without damage, and the wide track provided stability during deck operations in rough seas. The tailwheel was steerable, giving the Swordfish good ground handling characteristics. The arrestor hook, essential for carrier operations, was a simple steel hook that could be lowered manually from the cockpit. The engine installation was designed for accessibility. The Bristol Pegasus engine was mounted on a fireproof bulkhead with quick-release fasteners. Maintenance crews could remove the entire engine in less than an hour if necessary, though most maintenance could be performed with the engine installed. The engine bearers were designed to absorb crash loads, protecting the crew in the event of a heavy landing or crash. Weather operations and extreme conditions. One of the Swordfish's most remarkable capabilities was its ability to operate in weather that would ground virtually any other aircraft of its era. The combination of low stalling speed, excellent low-speed handling, and robust construction meant that Swordfish could take off and land from carriers in conditions where more modern aircraft would remain in the hangar. Arctic operations presented the most extreme challenges. Temperatures of -40 degrees Fahrenheit were common on Arctic convoy escort missions. At these temperatures, metal becomes brittle and can crack under stress. Control cables could freeze and instruments would malfunction, but the Swordfish, with its simple construction and fabric covering that could flex without cracking, continued to fly. Maintenance crews would preheat engines using portable heaters before starting them, and they would add special cold weather oils and greases to reduce the risk of equipment failures. The fabric covering actually provided an advantage in extreme cold. Fabric would not become brittle like metal, so the wings could flex normally even in Arctic conditions. The simple mechanical systems, with their large tolerances and robust construction, were less susceptible to freezing than the more sophisticated systems in modern aircraft. Pilots learned to tap instruments before reading them to break any ice that had formed on the internal mechanisms. Tropical operations presented different challenges. Heat and humidity affected both aircraft and crews. The fabric covering had to be frequently inspected for signs of mildew or rot, and affected areas had to be patched and redoped. The heat could cause fuel to vaporize in fuel lines, leading to vapor lock and engine failures. Crews working on aircraft in tropical heat faced the risk of heat exhaustion and needed frequent rest and hydration. Mediterranean operations combined elements of both extremes. Summer operations meant heat that could make metal surfaces too hot to touch, and would fatigue crews operating in exposed cockpits. Winter operations could bring cold rain and rough seas. The Swordfish operated effectively throughout these seasonal variations, demonstrating adaptability that was one of its greatest strengths. The human cost. While celebrating the Swordfish's achievements, it's important to remember the human cost. Hundreds of Swordfish crew members died in combat operations throughout the war. The slow speed and light defensive armament made the aircraft vulnerable, and crews attacking heavily defended targets faced enormous risks. The losses in daylight operations were particularly severe before tactics evolved to emphasize night attacks. The psychological strain on crews was significant. Flying slow, vulnerable aircraft into intense anti-aircraft fire required extraordinary courage. The knowledge that a direct hit could tear the fabric aircraft apart or set it on fire, and that parachutes offered little hope of survival over cold ocean water, weighed heavily on crews. The loss of friends and squadron mates affected morale. Though the traditions and esprit de corps of Fleet Air, armed squadrons helped crews cope with losses and continue flying missions. Casualties among Swordfish crews included not just those killed in combat, but also those lost in operational accidents. Night operations, particularly carrier landings in darkness and bad weather, were dangerous even without enemy action. Aircraft would occasionally miss the arrestor wires and crash into the barrier, or go over the side into the sea. Navigation errors could lead to aircraft running out of fuel and ditching far from help. The cold waters of the North Atlantic and Arctic meant that ditched crews had only minutes to survive unless rescue was immediate. The rear gunners, sitting in the exposed rear cockpit with only a rifle-caliber machine gun for defense, were particularly vulnerable. If the aircraft was attacked by fighters, the rear gunner faced the attacking fighters directly, manning his inadequate gun while enemy cannon shells and machine gun bullets tore through the aircraft. Many rear gunners were killed or wounded by enemy fire that passed through the aircraft. Their courage in continuing to man their guns while under attack earned the respect of pilots and observers who flew with them. Strategic significance in the broader war. The Swordfish's contribution to Allied victory extended beyond its direct achievements in sinking ships and submarines. The aircraft's presence forced the Axis powers to divert resources to defence. German and Italian merchant ships required escort vessels, whose crews and weapons might otherwise have been used offensively. Coastal waters had to be protected by anti-aircraft batteries and fighter patrols, tying down resources that could have been used elsewhere. The psychological impact of Swordfish attacks on Axis forces should not be underestimated. German and Italian sailors knew that at any time, especially at night, Swordfish could appear out of darkness to attack their ships. This constant threat affected morale and made coastal and convoy operations more dangerous. The knowledge that even heavily defended battleships like Bismarck could be crippled by Swordfish attacks made German naval commanders more cautious, reducing the effectiveness of the Kriegsmarine's surface fleet. The Swordfish's success also demonstrated the value of carrier-based aviation at a time when this was still being debated. Before World War II, many naval officers believed that battleships were the decisive weapons at sea and that carrier aircraft were auxiliary forces. The Swordfish's achievements, particularly the attack on Bismarck and the raid on Taranto, demonstrated that carrier aircraft could accomplish what surface ships could not. This lesson influenced post-war naval aviation development in all major navies. Jagdas. Final reflections. The Fairey Swordfish's service record stands as a testament to the principle that practical effectiveness matters more than technological sophistication. In an era of rapid technological advancement, when aircraft designs were becoming obsolete within months of their introduction, the Swordfish remained effective throughout the war because it was designed to do a specific job and did that job well. Its designers had prioritized reliability, maintainability, and suitability for carrier operations over speed and modernity. These priorities proved correct. The aircraft's nickname, the string bag, was initially mildly derogatory, suggesting an old-fashioned and somewhat ramshackle aircraft. But the crews who flew Swordfish came to use the term with pride and affection. The string bag could carry almost anything, could operate in almost any conditions, and could bring its crew home despite battle damage that would have destroyed other aircraft. These qualities earned the deep respect of the men who flew and maintained them. When aviation historians rank the most important aircraft of World War II, they typically focus on fighters like the Spitfire, Hurricane, Mustang and Messerschmitt 109. or bombers like the Lancaster, B-17 and B-29. The Swordfish is often overlooked in these rankings, yet its contribution to Allied victory was substantial. The tonnage of enemy shipping sunk, the U-boats destroyed, the convoys protected, and the strategic impact of attacks like Taranto and the crippling of Bismarck give the Swordfish a claim to being one of the war's most effective aircraft despite its obsolete appearance. The story of the Swordfish resonates because it contradicts expectations. We expect modern, sophisticated weapons to be effective and obsolete weapons to fail. The Swordfish defied these expectations, proving that courage, skill, and appropriate design can overcome apparent technical obsolescence. The fabric-covered biplane flying at speeds a car could match became the aircraft that helped win the war at sea, an outcome that would have seemed impossible to anyone watching those Swordfish approach Bismarck on that stormy evening in May 1941. The legacy of the Swordfish lives on in the principles of military aviation. Reliability, maintainability, versatility, and suitability for actual combat conditions remain more important than impressive performance specifications or sophisticated systems. The Swordfish proved these principles in the most demanding testing ground imaginable. Combat operations throughout World War II, from the Arctic to the tropics, from the first days of the war to the final victory. When Lieutenant Jabs laughed at the approaching Swordfish, he was making a reasonable assessment based on appearances. The ancient biplanes looked absurd attacking a modern battleship, but his laughter demonstrated a fundamental misunderstanding about what makes weapons effective. The Swordfish looked obsolete, but it had qualities that made it deadly effective against targets that more modern aircraft might fail to defeat. Its slow speed confused German fire control systems. Its fabric construction allowed it to absorb battle damage. Its simple, robust design meant it could operate in conditions that grounded sophisticated aircraft. And most importantly, it was flown by extraordinarily brave and skilled crews who pressed home their attacks regardless of the odds. The transformation from object of mockery to instrument of victory was complete when Bismarck's rudder jammed and the great battleship began her death spiral. The string bags had done what seemed impossible. They had proved that old could defeat new, that simple could defeat complex, and that determination and courage could overcome apparent technological inferiority. This lesson, learned over the cold North Atlantic in May 1941, remains valid today. The slowest combat aircraft of World War II helped win the Battle of the Atlantic and sink the pride of the Kriegsmarine, achievements that speak to enduring truths about war, courage, and the human spirit that transcend technology and time.